Dear students, through this video, we'll solve the problem with the help of Scilab. Compute the eigenvalue and eigenvector diagonal matrix in order to reduce the this quadratic form into the canonical form through orthogonal reduction. But to do the problem, we have to convert the given quadratic form into canonical form. I hope you have an idea how to convert a quadratic form into canonical form. The square element coefficient should be represented the diagonal element. So the first you have x square whose coefficient is 1, that should be the first diagonal element, and y square coefficient is 5, that is second diagonal element, and the third diagonal element becomes a z square coefficient, that is 1. And the remaining part, I think, I hope this number denotes the coefficient of xy and whose off value, that is the value of xy coefficient is 2, and if we are dividing that one with the 2, you are getting 1. Therefore, this element becomes 1. And after you are getting the coefficient of xz is 6, therefore off value of that one is 3. That's why we are representing this. The first row, third element becomes what? 3. In a similar way, we can fill the remaining. We got the A matrix. Now, we'll find the eigenvalue, eigenvector and diagonal matrix, and after you can, with the help of that one, we can form a quadratic form. We can reduce the quadratic form into canonical form. So I will go to Scilab now. The Scilab command window, first I will get the A matrix. The A matrix is equal to, we are getting 1 1 3 1 5 1 1 1 3. It is a matrix, as I told earlier in that earlier video. I will start with the array 1 1 3, and the second row should be splitted with a colon. Second row is 1 5 1, therefore 1 5 1. It should be splitted with a colon. Next, the third row is 3 1 1. 3 1 1. We can close the square bracket, and we stored this matrix in A. Now I want to find the eigenvalue, that's why I am typing SPEC of A. SPEC of A. Then you are getting the spectrum, that is nothing, the eigenvalues. 2, 3, 6 are eigenvalues, we find it. Next, I want to find the diagonal matrix and eigenvector. That's why I am going to type square bracket x space d, that is x denotes here eigenvector matrix, that is model matrix, and d denotes a diagonal matrix. That too I need. That's why I am closing with the square bracket and equal to SPEC of A. This must be the code syntax for to find the eigenvector and also eigenvector matrix and diagonal matrix. If you are pressing enter button, we are getting the answer. We got the eigenvector and diagonal matrix. With the help of this diagonal matrix, we can conclude the answer for the given problem is -2, 3, 6 are eigenvalues, and similarly the diagonal elements of the diagonal matrix. Therefore, the canonical form for this one is -2 y1 square plus 3 y2 square plus 6 y3 square. Thank you, students.